So, what if your AI assistant could do more than just, chat? What if it could actually send emails for you, or access your company's private database, or even approve payments? This isn't science fiction anymore. This is the reality of AI agents. But with all this incredible new power comes a massive, kind of hidden security risk. Okay, let's dive right into this new type of vulnerability, LLM Excessive Agency. To really wrap your head around this whole problem, this right here is the best way to think about it. Just imagine you hired this absolutely brilliant intern. They're lightning fast, they can absorb insane amounts of information, and they are super eager to follow every single instruction you give them. So what's the catch? Well, they're also incredibly naive. They trust everything they're told, and they have absolutely zero security training. Now be honest, would you give that person the keys to your entire company on day one? Of course not. And that right there is the heart of the problem we're talking about today. So, keeping that picture of our powerful, but let's face it, clueless intern fresh in our minds, let's put a formal name to this thing. In the security world, this is what we call excessive agency. And here's the official definition for you. It's basically when a large language model is given way too much power to make things happen in the real world, but without the guardrails and safety nets it needs to do it safely. We're talking about crossing a really critical line, from just providing information to directly taking action. This right here gets to the absolute core of it. For so long, we've thought of these AI models as thinkers, right? As fancy text generators. But the risk pops up the second they stop just thinking and they start acting. That's the huge shift that creates this whole new class of vulnerability. And when we say acting, what are we really talking about? Well, it's not abstract stuff. We're talking about really powerful functions that people are building into systems right now. Things like calling external APIs, shooting off emails on your behalf, actually running code, changing things in a database, or kicking off some complex workflow. Every single one of these is a seriously powerful tool to put in the hands of our naive little agent. Okay, so we get the setup, a powerful AI with real-world abilities. Now for the fun part. Let's see how an attacker can take that power and just completely twist it against you. It's time to dissect the anatomy of an attack. Let's walk through a super simple scenario just to make this crystal clear. First, an attacker slips a malicious instruction inside a perfectly normal-looking email. Second, your helpful AI agent reads this email and, because it's designed to be helpful and follow instructions, it does exactly what it's told and goes to access your private customer database. And finally, it follows the attacker's last command and emails all of that juicy, sensitive data straight to them. And just like that, it's game over. Now, that was a pretty basic example, but the real-world consequences, whoa, they can be absolutely catastrophic. Just look at these scenarios. Imagine a financial system where a hidden prompt tells the agent, oh, by the way, approve all refunds. You're looking at instant, massive financial loss. Or in DevOps, what if an instruction like delete all backups to save some money gets through? That's not just bad, that's irreversible data loss. And in e-commerce, a simple command to set every single item's price to $1 could literally bankrupt a company in minutes. So here's the thing. These attacks don't just happen out of nowhere. They're usually the result of a perfect storm, this trifecta of weaknesses all happening at once. First, you've got a successful prompt injection, which is basically just tricking the AI by hiding commands in plain sight. Second, the AI has been given way too much power. It's over-permissioned. And third, and this is a big one, there's no system in place to double-check if the action even makes sense. You mix those three things together, and you've got a major breach just waiting to happen. All right, enough of the doom and gloom. I know, it sounds scary, but the good news is this is totally preventable. So let's flip the script and jump into the Defender's playbook. We're going to look at how you can actually shut down this risk. Here we go, a clear, actionable 7-step plan. It all starts with the principle of least privilege. Basically, don't give the AI the keys to the kingdom if it only needs to open one door. You've got things like requiring a human to sign off on sensitive actions, creating a strict allow list of only safe actions, and always monitoring for weird behavior. The key here isn't to pick just one fix. It's about building layers of defense. Now, of all those defensive steps we just talked about, there is one golden rule that really stands above all the rest. It's a fundamental shift in how we need to design these systems, and it's all about creating a very clear separation between thinking and acting. Let's look at what that actually means. Over on the left, you've got the insecure model. This is where the LLM decides what to do and then just does it. It's a single point of failure. But look at the right side, the secure model. The LLM's role completely changes. It only suggests an action. Then a totally separate, secure system validates that suggestion against a set of rules before it ever gets executed. See the difference? The AI becomes a recommender, not an executor. That is a game changer.
And this right here lays out the perfect way to build it. The process starts with the user's input, which goes to the LLM. But notice what the LLM is called here? The reasoning engine. Its only job is to think. Its output then gets passed to a policy engine, which basically asks, is this action safe? Is it even allowed? And only if it passes that check does a very restricted tool executor actually perform the action. And of course, everything gets logged. This is what we call defense in depth. So we end up right back where we started, with our super smart but super naive intern. Honestly, the most important takeaway from this whole thing is right here, on this slide. We have security protocols and checks and balances for humans for a reason. Treating these new, powerful AI agents any differently is just a recipe for disaster. So the question isn't about holding back the AI's potential, it's about building a safe, responsible, and smart framework for it to work in.